Okay, 3.5 dividing polynomials. Today we're going to do synthetic division. Okay, so synthetic division is the short form of doing long division. Okay, so a shortcut for long division of polynomials is synthetic division, where the divisors take the form x minus k. It cannot be used for any other divisor. Okay, so here coefficient must be, okay, 1 when it's written in this form. The pattern for a higher degree polynomial is as follows. Okay, so here's the pattern. So to divide some polynomial by x minus k, if you think about x minus k and you think about finding the root of it, you would say, okay, when does x minus k equal 0? Bring over the k. Well, when x equals k. Right? So this right here, you want to put the actual root. And then what we're doing is we're going to put a, b, c, and d. Okay, we're familiar with this. We used a, b, c in quadratic formula back in grade 10 and grade 11. Okay, so we're familiar that we name the coefficients in order, a, b, c, d. Okay, this time we're extended to like the 4 terms. So what happens is immediately a comes down. You do nothing. Then you take your root and you times it by a and you put it here. So this will be ka. Then you add these. So this is going to be b plus ka. Then you multiply. So the vertical pattern is like you add the terms, and the diagonal pattern is you multiply by k. And when you get to the end, this last term is the remainder. And these numbers are going to be your coefficients in ax squared plus bx plus c in this case. Because obviously if we're going from an x cubed term and we're dividing it by some term x minus k, so x to the 1, then we're going to get an x squared. Right? We're going to get a quadratic. All right. When we do these questions, it's actually going to be so much easier. So divide each of the following using the synthetic division. Write your answer as a division statement. So x to the 4 minus 10x squared minus 2x plus 4. We're going to divide that by x minus 3. So our root is x equals 3. Now we have 3, and we want to put the coefficients. So coefficient 1 goes here. There's 0x cubed. So just like long division, we have to fill in those numbers. Okay, there's negative 10x squared, there's negative 2x, and then there's 4. So no matter what, the first number you just bring down. Now, 3 times 1 equals 3, and add them. 0 plus 3 is 3. So multiply down, or sorry, multiply diagonally, and then add down. 3 times 3 is 9. Add these two. Put a plus sign. Negative 10 plus 9 is negative 1. Multiply down, so I get negative 3. Negative 2 plus negative 3 is negative 5. Multiply down, I get negative 15. 4 plus negative 15 is going to be negative 11. So when we read this, the last number is the remainder. That means that this is the constant, this is the x term, this is the x squared term, and then this is the x cubed term. So this written as a polynomial is x cubed plus 3x squared minus x minus 5. So the division statement. we have the original, x to the 4 minus 10x squared minus 2x plus 4. And I just got the original f at x from here. This equals the divisor, and we're dividing this by x minus 3, times the answer, the quotient. Remember dq, just like the ice cream. Okay, so we write the quotient in there, and then plus the remainder, so negative 11. Now b, we have x cubed minus x plus 28, and this is going to be divided by x plus 3. So there is no x squared term, so we're going to fill in the x squared term with a 0. So first, what is our actual root? Well, our root is x equals negative 3. So we're going to write negative 3 on the outside, and we're going to write the coefficients 1, 0, negative 1, 28 in our division. Okay, no matter what, the first term just comes down. And now we go, so this is a 1, and we go negative 3 times 1 is negative 3, and now add. Negative 3 times negative 3 is 9, and then 9 plus negative 1 is 8. Now, negative 3 times 8 is negative 24. Add these, we get remainder 4. So again, we read this as the constant, the x term, and the x squared term. So we read this as x squared minus 3x plus 8. Okay, now the division statement. So we say the original, which is x cubed minus x plus 28, equals dq. So our divisor is x plus 3. Our quotient is what we get as the answer. And then we're going to take along plus 4 as the remainder. Okay, as a correction here, sorry, coefficient must be 1. We don't need that because we can just like solve for the root when this equals 0. The x must be degree 1. Okay, it can't be degree 2. If we're dividing by a degree 2 or degree 3 or so on, we have to use long division. Example 2. X plus 2 is a factor. Okay, we've seen this before. Of this function, explain. Okay, I'm going to show it. Okay, so x plus 2, what that means is that we have a remainder 0. So the root on x plus 2 is going to be x equals negative 2. So we get negative 2, and then let's write out the coefficients. 3, 4, negative 18, negative 3. Okay, so let's show what this means. We bring down the 3. Yes, it is a 3 this time. It's not a 1 anymore. Okay, whatever number is here, that's fine. You bring it down. We do the same steps. Negative 2 times 3 is negative 6. Then we add. We get negative 2. Negative 2 times negative 2 is 4, and then we add. We get negative 14. Negative 2 times negative 14 is 28. Add these, we get 25. So, sorry, going back to this, it's asking, is x plus 2 a factor of this, and explain. So, again, when we have a factor, a true factor, we have remainder 0. What remainder do we have here? So, therefore, x plus 2 is not a factor of f at x because the remainder does not equal 0. And guys, this is going to come back when we formally do remainder theorem. There's a whole theorem based on this principle. So synthetic division with a divisor, ax minus k. So this time we're looking at the coefficient of non-1. So like a does not equal 1, essentially. So a requirement of synthetic division is that the divisor is in this form. And that's what I kind of talked about earlier. Like it's that form, but it doesn't matter because when you solve for the root, it just figures itself out. Okay, so we require it to be linear and it has a leading coefficient of 1. If the divisor has a different leading coefficient, we can make it work by breaking the problem into 3 steps. Okay, so instead of writing out ax minus k, what we can do is we can factor out the a and then bracketed x minus k over a, right? Because when you common factor, this is what it would look like. We can use synthetic division with this divisor, right? Coefficient 1. And then divide the resulting quotient by a. I think that this is what I would probably forget. Because the other, like, steps 1 and 2 are basically the same. All right, so let's do this. The function 2x cubed minus 15x squared plus 4x plus 21 is divisible by this. So if we factored out a 2, we would have x minus 3 over 2. Right? As a review, common factoring divides both or all terms by the same number, and then we'd have x minus 3 halves. Okay, so this is saying the function is divisible by this. This means, like, little hint, the remainder is going to equal 0 when we're done. So what is the root? The root is x equals 3 over 2. So 3 halves, and then we're going to put the coefficients. 2, negative 15, 4, 21. So bring down the 2. What's 3 halves times 2? Okay, side of your paper, 3 halves times 2. Well, those just cancel. I get 3. Okay, and add this. So negative 15 plus 3 is going to be negative 12. 3 halves times negative 12. So 3 halves times negative 12. I mean, you can do this the expanded way. You can say, okay, that's negative 36 divided by 2. I get negative 18. Now, negative 18 plus 4, I get negative 14. 3 halves times negative 14. Again, 3 halves times negative 14. I'm going to divide 14 by 2, and we're left with 7. So 3 times negative 7 is negative 21. Ah, check that out. When we add 21 and negative 21, our remainder is 0. So we have 2x squared minus 12x minus 14. But here's the thing. See this 2 here? We'd factored it out. So step 3, divide the resulting quotient by a. Well, if we actually look at this, we can divide by like 2. And 2 is because it's like a common factor. Okay, so now we're at x squared minus 6x minus 7. And the question asks, determine the other factors. Well, no biggie. We know x squared minus 6x minus 7 is just a trinomial. Back to grade 10. What two numbers multiply to 7, negative 7, and add to negative 6? Well, 7's a prime number, so we have 1 times 7, and we would have to put the negative sign on the 7, because negative 7 plus 1 is negative 6. So we would get x plus 1, x minus 7. So the other two factors are x plus 1 and x minus 7. And then the zeros are x equals negative 1 and x equals 7. I'll write a conclusion. Okay, so here's our conclusion. Here are the factors. Here are the zeros for the entire question.